So how do computers store images? Now there are many ways this can be done. However, we're going to look into the default method utilized by OpenCV, which is RGB. RGB stands for red, green, and blue. So imagine this 10 by 10 grid I have here represented an image, and at each pixel point, which is what these cells are, we have three values, one for red, one for green, one for blue. Now OpenCV stores these values as an 8-bit integer. 8 bits allows us to go from 0 to 255, giving us 256 values. So now we represent colors here by mixing different intensities of red, green, and blue. So as we can see in this pretty childish drawing here, all these values here are going to be white. White is represented by 255 in each color. So that's 255 for red, green, and blue. Next, if we have a green over here, pixel 04 is going to have 0 red, 0 blue, but full green. Now, how do we make colors like brown and yellow? Now, if we mix colors, as you may have done in kindergarten, I guess, you can see that by mixing red and green, you actually create yellow. Now, that's actually how we represent color spectrum using RGB, by mixing different combinations of colors of different intensities, and that's what these values are, by the way. They are color intensities. So a value of red that's low is going to be a dim, dark value, and one that's 255 is going to be a bright red, similar to this shade here. Now this picture of the Eiffel Tower, which I blurred, not actually resized, so that we actually have a very low green pixel count, you can see the individual pixels here, and you can actually see that there are different shades of yellow and brown and black. So that's exactly how we use RGB to represent images. Now I've talked a lot about how RGB is used, but I haven't talked a lot about how it's stored in a computer. So that's what we're going to look at next. So this scary looking thing here is actually how computers store images. This mess basically represents a 100 by 100 pixel image, where each point goes from 0 to 255 as we saw previously. And these are the colors the color intensities for blue, green, and red. If you're familiar with programming, you'd quickly realize that this data can be easily stored in arrays, and that's exactly how OpenCV stores images. If you're unfamiliar with arrays, I'll give you a quick introduction before we go into any coding. First, think of an array as a table, where each cell is identified by its location, which is called its index. So in a one-dimensional array, you have one row of information, and each cell is identified by the index number, which is 0, 1, 2, and so on. In a two-dimensional array, we have multiple rows now. So now we need two numbers to identify individual cells. So imagine this cell right here with my mouse cursor over is going to be identified by position 1, 1. Think of it like an XY coordinate system. So now we move on to three-dimensional arrays, which is what we use in OpenCV to store images. So in a three-dimensional array, think of the same two-dimensional array, but with layers of stacks behind them. So as you can see, in this first stack here, we have the red values, then behind it the green values, and blue values, and so on. So what this means now is that each cell is identified by three numbers now. We have 0, 0, and a third 0 here. 0, 1, and 0 to represent the red. If you wanted to find the green value, it would be 0, 1, 1. So that's essentially how RGB images are stored in arrays in OpenCV. So what about black and white or grayscale images? Now these are actually simpler. These don't have a third dimension. In fact, they are just stored in a two-dimensional array. So instead of having multiple layers, we just have a single layer like this, and with each coordinate position, there's a value associated with it, and that value in a grayscale image basically represents shades of gray, and there are 256 shades, not 50. And as you can see here, darker colors are represented by lower values. Previously we saw white being represented by high values, and that follows suit here. So now we have a full spectrum of gray for an image. This is an image of a number 1, by the way. So what about binary images? Binary images can also be called black and white images. However, they are just 2 values used, 255 and 0. Binary meaning 2. So it's either max or min type system.